Hi guys, we're about to start on the Chapter 8 Confidence Intervals Reading Guide. So this is Chapter 8 Confidence Intervals, and it starts on page 439. Alright, on page 440, quickly, the point estimate depends on if we're talking about the mean or the standard deviation, but the point estimate for this first part, x bar, is a population mean, and that the point estimate for the standard deviation, S is for the sample and sigma is for the population. Okay. And then this part right here, this is key. A confidence interval is another type of estimate, but instead of being just one number, it's an interval of numbers. And it's the interval of numbers is a range of values that are calculated from a given set of sample data. The confidence interval is likely to include an unknown population parameter. All right, so now with the confidence interval, we're still doing an estimate, but it's going to help us estimate where the mean or a proportion might lie. All right, so similar to the empirical rule, which states that so much data is in between this value and this value, saying that it's within one standard deviation of the mean or two standard deviations or something like that. A confidence interval allows us to say that we are, whatever that percentage is, like on this one it's 95%, that we're 95% confident that the unknown population mean lies between 1.8 and 2.2 for this confidence interval. Okay? So really what that's saying is that that interval will contain the true mean for our population. Right, and the way that we get that is we have to include this margin of error, or an EBM. So we're going to take that point estimate and we're going to add and subtract that point estimate from our margin of error. Okay, so this would give our lower bound and our upper bound. Later on we'll call that the EBM. Alright, so we are still going to be using the normal distribution to find a single population mean. We will do some later on that have more than one, but for right now we're just going to be using one. To calculate the confidence interval, we need to have our x bar, our mean, and we need to have the margin of error. Okay, that's the EBM, or the error bound. That margin of error is what's going to help us find our range. So this is how we're going to have it. We know that x bar, and then we can figure out the EBM and then subtract and add that. In this one, they kind of go through a different way to get it, but there's a faster route working backwards, and Mr. Shaw uses it too, so I'm going to show you that way rather than take you through the long route. Alright, so when we're talking about confidence level, and again, the confidence is going to be the range. We're pretty sure that the population mean is going to be we want 80% or higher, because there's no reason in having any less confidence than that. You want to be pretty confident about your conclusions on this. Okay, so confidence level is going to be abbreviated CL. Alright, so on page 442, this is a good visual on what we're actually doing here. So we're given that our sample mean is 10. Okay, so our sample mean is 10, and that we have a confidence interval from 5 to 15. So from 5 to 15, that we're 90% confident that the real or the true population mean lies within that range from 5 to 15. So our EBM, or our error bound, is going to be 5. We go 5 higher and 5 lower than the sample mean. Alright, so let's talk about the EBM. So to calculate the EBM, you have to do d-square and do additions. If you do it forward, that's why it's going to be easier if we do this backwards. Okay, so we want to do it the forward ways, but it's going to be a lot easier if we do it the backwards way. Alright, so we're going to go through example 8.3, and I'm going to use this backwards method because it's a lot easier. Alright, so a specific absorption rate for a cell phone measures the amount of radio frequency energy absorbed by the user's body when using a handset. Okay, now they're going to give this table. It's on the next page. All right, so we have all this table, and you can type this into your calculator to find our point estimate. In other words, to find our x-bar. So you would type in all of these data points to come out with our x-bar. All right, so once you've done that into your calculator, you find that your x-bar, or your point estimate, is 1.024. Okay, so now we're going to find a 95% confidence interval of where the true population mean for the specific absorption rates for cell phones. We're going to assume that the population standard deviation is sigma, is our 0.3337. All right, now the other piece of information that we need to have is our number of our sample. Okay, so in this case, we're given the table of data, and we have 30 data points, so the number from our sample is 30. We can use the central limit theorem to approximate the normal distribution because it's greater than or equal to 30. So that lets us use the normal distribution, and that's one of the required checks that we need to make sure we do before we go through on the rest of this. Okay, so we are given the population standard deviation. We have our estimate point or sample x-bar, and we have our sample number. All right, so the way that we do this is we're going to go to stats, not distributions. Go to stats, and we're going to go to the tests. We're going to use the z because we have the population standard deviation. So we're going to come down here to the z interval, because that's what we're looking for, is our confidence interval. So the z interval, and we're using the z because this is, we know the population standard deviation. Okay, now we're going to go off of the stats because those are the pieces that we know. Okay, if we wanted to put in the data, we could, but that would just be entering in all of those points again. Okay, so we know our population standard deviation is 0.337. We have our sample point, 1.024, and our n is equal to 30, and we're going to do a 98% confidence interval. Okay, so what we're going to do here, go through and calculate, and now we have our confidence interval is 0.88087 to 1.1671. Alright, so now that we take a look at this, we're going to use the normal curve to kind of explain this. We've got our point estimate at 1.024, that's right here. And to calculate the EBM, we just need the distance that our range is from the point estimate on each side. Okay, we've already calculated this. We've got these two values, so we just need to figure out that distance, and it's going to be the same on each side. So this is 1 EBM, and so is this. So if I just take my point estimate of 1.024 and I subtract 0.88087, then that's going to tell me my EBM. Alright, so if I do 1.024 and I subtract 0.88087, then that tells me EBM is 0.14318. Okay, so this is backwards method. Find your constant interval first, and then you subtract the difference between the point estimate or your x-bar from either end. Doesn't matter. We chose to do the lower end, so the EBM would already stay positive. But really, it's just the distance that we want it to be. This is the backwards way, which is a lot easier than using that complicated form the text is giving you. Alright, so this is on page 447. Just kind of walking through what we did on the calculator. You're going to go to stats and then use tests. We're going to do the z interval. The reason we're using this one is because we know the population standard deviation. In other words, we know sigma. Okay. Then we enter in the data we have. We know the sigma. We know the x-bar, and we have 30 data points. We're doing our const level at 98%. Okay, and then that gives our confidence interval. All right, so I'm going to jump back to page 444. This is how we interpret our confidence intervals. And this is going to be the same for every time that we use our interpretation. And Snow's really, this is the whole point of it. This is inferential statistics, so we need to interpret what all those numbers mean. So we estimate with 98% confidence that the true population mean, and this one has to do with absorption rates for cell phone use, is between, and then you put in your appropriate values, and on this one it was the 0.88 something and 1.03, whatever it was just a minute ago. Okay, but this is that same format. The only things that are going to change are your confidence level, the context of the problem, and your interval. Now, this is always going to be for means, but we're going to do this later on for proportions. Okay, but for right now, this is what it's going to be for your interpretations for the population mean. So it's going to be that the true population mean lies between those two values, and we can say it with that level of confidence. All right, so this is on page 450. Working, that's what we just went through. It's a much easier to get there. Okay, so you find to find the error bound. You get your first. Subtract endpoints from your sample mean or your estimate. So that's just went through. This is one on page 450. And it's the working backwards method, and it's a whole lot easier than trying to do it the other way. Okay, this is on page 451, example 0.6. Then the confidence interval, how you can find your EBM, your error bound, and you can also find the sample mean. So if we know that this is our confidence interval, then we just have to find the middle of it to find our mean. So this part down here, we're just subtracting the two, finding the middle, and that's going to be the sample mean. So you do find the distance that you have in your bound, and then basically finding the middle. All right, so just remember that you're just finding the average to find the middle. So we add the endpoints together, divide by 2, that tells us the middle. If we find the distance and then divide by 2, that's the EBM. Okay, one last thing in this section is to find the sample size. You can use your z-score and your population standard deviation and your EBM to figure out your sample size. Chances are this is unlikely to be necessary, but just in case. So this is how you'd calculate your sample size.